section 6.6 is we're going to be working with graphing more in today's lesson. And then we're also in 6.7 going to talk about the solving of systems of equations. So up to this point, we've really only solved one equation independently. So the next lesson, 6.7, we'll put more than one into play and we'll solve them jointly. So first, if you were wondering what I was up to, well, you have to know I was plotting something, or, well, I'm about to. Okay, that's a terrible pun, but let's go with it. So a quick little review of plotting points, or plotting ordered pairs. Remember that an ordered pair is an x, y coordinate, and then we have the coordinate plane right over here. And we can go ahead and just put little points on the plane based off of the coordinates given in A through F. So in the first one, we have -3, +2. So this is the x coordinate and this is the y coordinate. So what we would do is we would start right here at the middle, which is sometimes referred to as the origin, which happens to be F. We'll say that later. But what we'll do is we'll start here. We'll go -3 along the x-axis, which is the horizontal axis. And then we're going to go from there. We're going to go 2 up, which is the y or the vertical axis. So right where I ended is where I'll put a point, and this is point A. So I don't think the homework talks about this, but in case you had forgotten, we start in this upper right-hand corner. We call that quadrant 1. Then we go counterclockwise. That's referred to as quadrant 2. The lower left is quadrant 3. And the lower right is quadrant 4. And now those Roman numerals should not give you any sort of trouble since we already learned those back in section, what was that, chapter 4. Feels so long ago, right? But anyway, let's go ahead and look at a few other ones. If we look at point B, this time we have x of 3 and a y of 2. So we'll go to the right 3 and then we'll go up 2. So we end up right here in the first quadrant. So there is point B. Point C, again, x is going to be +4, y is going to be 0. So this one, we end up just going to the right 4 and we don't have any upward or downward movement. So there's point C. Okay, before we do this, let me just pose a quick question based off of what we've been doing. Point D, -5, -1. What quadrant is this point going to be in? What do you say? Indeed is going to be in 3. We'd go -5 and then we'd go down 1, so we would end up right here. All right, and then, so let's label that point D. Point E is just going to go straight down, which is going to be a -3. So right there is going to be point E. And as mentioned earlier, point F is going to be right here in the middle. That is sometimes referred to as the origin because all of the points originate from that. Any questions on plotting points? All right. By the way, I hope this makes you happy because there's a little face hidden in these points. So you don't need to actually do the connections. I intentionally picked those points to make you smile. Makes me smile at the very least. All right. Now that we've got to the point, let's go ahead and look at ordered pairs and their relationship to equations. We are asked to determine if the ordered pair satisfies the equation x plus 3y equals 13. If you remember, I think last week we talked about checking if a number satisfies the equation. We just had a single variable. Here we have 2. So again, you'll just take the x, you'll look at the y, and you'll look at the equation, which in this case was x plus 3y is equal to 13. And we'll just go ahead and plug in the x and the y in the appropriate location and see if it simplifies to a true statement. So I'll go ahead and let me zoom in here. We'll go ahead and put the x in there, and we'll go ahead and put the y in there. So this is going to be 0 plus 3 times -1 is equal to 13. And because we're checking if it satisfies, we're really not making that statement. We're asking, is this equation true? And if you go ahead and simplify this, you would have 0 minus 3 equal to 13. And at some point, you'll be able to determine whether the answer is yes or no, and you'll see that the answer here is no. So the ordered pair 2, -3 is not a solution to the equation. It does not satisfy it. Any questions on 2? All right. Number 3 is going to be a similar process. I always just try to show enough work that I don't make a mistake. So I just rewrote the equation, and I'm just kind of drawing arrows. So the x right here goes to 10, and the y here goes to 1. So 10 plus 3 times 1, we're checking, is that equal to 13? And again, this one's pretty straightforward. 10 plus 3 is equal to 13. Indeed, 13 is equal to 13. So the answer to this one is yes. The point 10(1) is a solution to that equation. Any questions? Then let's go ahead and move on. I think it was appropriate that we were talking about skiing before class because we're also going to talk about slope today. Again, let me just pose this quick question. What letter do we typically associate with the slope of something? Just seeing if anyone remembered. M. I'm hearing M occasionally from here, and that is true. The slope, we're going to consider this slope, and we'll use the letter M for slope. And when we're talking about slope, we're really going to be talking about a line. The slope of a line measures the steepness of a line. So what we're going to be working towards now that we are plotting some points, now that we're looking at equations, we're going to go ahead and looking at graphing equations. And the one basic one we're going to look at today is the line. So the slope of a line passing through distinct points x1, y1, x2, y2 is given by this equation. M is equal to the change in y's, so that would be y2 minus y1 divided by x2 minus x1. And then what we'll go ahead and do is, by the way, this is of course the equation, but it's also good to think about this top right here is how much the line is going to rise, and the bottom is going to be how much the line is going to, what do y'all say? Run. Personally, I would have said walk, but running's good. My wife's the runner of the family, not me. Anyway, so you may remember slope is simply rise over run. In terms of the actual points, that's the change in the y values divided by the change in the x values. So in these next 4 examples, we're going to consider the 4 scenarios that we might have, which are down there at the bottom. We may have a positive slope where the line rises, a negative slope where the line falls. We may have a 0 slope where we have a horizontal line, or we have this scenario where m is undefined, which is a vertical line. So let's go. We'll run into each of those scenarios here above. Let me go ahead and just maybe do 2 of them and kind of get us set up, and then I'll go ahead and take attendance now that everyone else showed up. We prayed you here, basically, so awesome. So I'll go ahead and do 4 and 6 just to kind of expose you to the equation, make sure you're comfortable with it, and then I'll give you 5 and 7 while I take attendance. So let's go ahead and look at 4 together. So my biggest suggestion is to make sure you label things. It does not matter which ones you call your first ones and what one's your second one, so I just typically label in order. This is going to be my x1, this is going to be my y1, this is going to be my x2, and this is going to be my y2. And if you're not sure what to do, just ask R2D2. I really had to force that one. Okay, let's move on. So, now that these are labeled, we're going to go ahead and just label, we're going to find the slope. So we have the change in the y's, so that's going to be 4 minus a minus 1. And then we'll go ahead and divide that by minus 2 minus a minus 3. just to kind of color code where points are coming from. This 4 is right here. This -1 is right here. This -2 is right here. And I need one more color. Let's go ahead, and this -3 is right here. So, very colorful. Let's simplify this. 4 minus a -1 turns into 4 plus 1. And -2 minus a -3 is -2 plus 3. So this is going to be 5 divided by 1, or simply positive 5. So this is my slope, 5. Now it is worthwhile to just look at it in terms of a fraction, because that's telling us that the line's going to rise 5 and it's going to run 1. So if we were maybe thinking about how this would look, we will start like down here. We'd go like 1, 2, 3, 4, 5 up. Let me put that as a dashed line. We'd go 5 up, then we'd go 1 to the right. So we would have a line that essentially looks like this. And again, it's not on the coordinate plane yet. We'll do that here on the next page. But this is a line that is rising. Don't resist it. It's another Star Wars reference. Okay, that one fell flat. Okay. Let's go ahead and look at, well, let me post this first. Any questions on 4? All right. Number 6 will be a special case, and you might already be seeing that because if you look at let's label them first. So x1, y1, x2, y2. If you look at the y's here, those are the same numbers. So that's going to mean 0 is going to play in here. So we do want to be careful with that. So let's go ahead and do the computation. So m is going to be 3 minus 3, y2 minus y1. And we will divide that by 4 minus a -2. So 4 minus a -2. So this is going to be 0 over 6. And the thing to remember is whenever you have a 0 in the numerator, the slope here is actually going to be 0. If we had a slope in the denominator, we have a different case. But again, it's still useful to look at this as rising. So it's going to rise 0, it's going to run 6. So if it rises 0 and runs 6, you have a line that is just going to be flat or horizontal. Oh no, if you rise 0 and run 6, I think you're really more crawling than anything. Any questions on 4 or 6? All right. So I did the even ones. And I'll let you try these 2 odd ones right here. Go on and take a moment, try 5 and 7. All right, so here's the solutions. I'll talk through them just in case anyone needs to hear it. So labeling this is my x1 and this is my y1 and 2 is my x2 and -2 is my y2. I find the slope here is going to be -2 minus 4. And then in the denominator, it's going to be 2 minus -3. So this is going to be -6 over, let's see, this is going to be 2 plus 3. So we end up with -6 over 5. Now, it's worthwhile maybe just to mention right here that you actually might also see that negative in front, or you might also see that negative in the denominator. Those are all equivalent fractions. The one we'll use most commonly, though, is this one right here, because while we still say this is like rise, we're going to rise -6. So we would actually go like down 6, and then we're going to go ahead and run 5. So we would have a line that looks something like this. So it's a line here where the line is falling. No need to write that as a decimal or anything, but I wanted to make sure we did catch on to the idea that the slope here is negative. And that negative is typically viewed in terms of the numerator, but you could also run in the negative direction as well. If you did that, you would have went up 6, but you would have went -5. Oops, overshot that. Up 6, -5, you would have still ended up with the same line. Okay, how many got 5? Just to see how everyone's doing. Okay, good. Everyone's doing okay. If anyone has a question, let me know. Number 7 is maybe one of those questions that will occasionally just be missed because of a hurry or maybe just a quick little gap in understanding. So let's label x1, y1, x2, y2. And the slope here, you might also be noticing here we have matching x's, so that's going to lead us to a 0. But we end up with minus 4 minus 3 all over 2 minus 2, which is going to be minus 7 over 0. So this is actually, by the way, you are allowed to use a calculator on the test. So like, for example, if you don't remember what minus 7 over 0 is, you could just type in, let's see, minus 7, divide that by 0, and you're going to get some sort of error. Mine says overflow error or just overflow. So a good thing to remember here is that this is the scenario where m is undefined. So make sure you do actually complete the thought there and say, okay, if the problem's asking you for slope, you say it's undefined. And again, you can always use a calculator to verify that here. But just a quick reminder, no graphing calculators on this next test because we're about to graph. So make sure that you do secure a scientific calculator, something with no graphing capabilities before that test. If you're not sure if your calculators will work, talk to me that Tuesday after break. Okay. It's still good to go ahead and think about this as rise over run, though, because what this is saying, if you rise negative 7, you're just going to go straight down, and if you run 0, you're going to be just looking at a vertical line. So this is going to be a vertical line. So those are the 4 different scenarios of slope. How many got 7? Even the undefined part. Ooh, many of you. Very good. Any questions? You may want to star 7 and 6. I'll sometimes see on the test a little bit of a mix-up between which one's 0, which one's undefined. So just be careful with that. Now that we know about slope, we can go ahead and graph lines. So that's what this next page is going to be. We're going to really just use one form of the line. The one that we're going to use, let's see if anyone knows what the last letter of this equation is. It is y equal to mx plus b. If you all know that, you're going to get A's. Well, hopefully. There's still a little more to it than that. But very good. This right here is the point. No, sorry, mixing up. Calculus, we use point slope a lot here. This is the slope-intercept form of a line. So it's called the slope-intercept form because what we have here is m, this is the slope, and b, this is going to be the y-intercept. So the y-intercept is just the a number where the graph crosses the y-axis. You're going to use the y-intercept first, and then you'll go ahead and use the slope. So step 1 is to use the y-intercept, and then from the y-intercept, you'll use your slope. You could kind of think about this in life. Life is easier if you have your y, you know your purpose. So let's find that out first. In the case of number 8, we see that our b, our y-intercept, is going to be 4. So I'll just go ahead and put y equal to 4 right there. The common mistake I'll see on this one is people putting it on the x instead of the y. So that's why I made that little extra analogy. It's good to have your purpose or your y because then you know where to start. So you start with your y, in this case 4. And then here, I'm going to go ahead and just move it over to the side. M is 2, but it's sometimes easier to view this as not just 2, but 2 over 1. So you could then think about that as, okay, I have to rise 2, then I will run 1. So from my y-intercept, I'm going to go up 2, I'm going to go over 1, and I'm going to put a second point. Everyone okay with where I got those 2 points? Awesome. And then 2 points will define a line, so I could just go ahead and draw a line through those, and right there in green is our first graph. Any questions on number 8? All right. So, number 9, we have a negative slope. And again, we already talked about negative slopes. That's going to be a line that's falling. So again, I'm going to start by looking at the minus 3. I'm going to just label this off to the side. So b in this case is minus 3. So I'm going to start right down here at minus 3. Then our m is also minus 3. And remember what I said. You have some options where you put the negative. Most commonly, I'll want to go ahead and just put it at the numerator. We like to deal with that first. You know, sometimes if you're ever like Does anyone ever have those things that you're just dreading that you have to do? Try and knock those things out first. Then the negative parts are over with. So I'm going to choose to put it up at the top. So I'm going to go down 3, and I'm going to go over 1, and I'm going to have a second point right there. Draw a line between those, and I have my line for the equation given above. Any questions there? Now, we're really not going too much into depth here, but I'm going to just make a quick statement about this and how it connects to what we did earlier. We were looking for points that satisfy an equation, and a graph is just a visual representation of all points that would satisfy it. So if you were to plug in this point right here, as my graph's a little bit off, they should be hitting lattice points, but any point that's on the line, if you plug it in, would satisfy the equation. So a graph is just a visualization of all representation, or let me start that sentence again. A graph is a that's such a hard word. Visual. What you all said, visual, we'll just start with visual. Forget the eyes at the end. It's just a visual of all of the solutions to an equation. Wow, words are hard. It's a math class. Anyway, any questions on number 9? All right. You'll find that number 10 is very similar. Go ahead and try number 10. All right. The way you would approach number 10 is as follows. The b here is going to be minus 4. The slope is 5, which is, of course, the same as 5 over 1. So we go down to minus 4. From there, we rise 5. So 1, 2, 3, 4, 5. Run 1. So we have the line, the second point of the line right there. Draw a connection between them. And we have the graph. Any questions on that one? Okay. On number 11 through 13, we have like a step 0 to do. And what we need to simply do if we are not solved for y already, we need to go ahead and just manipulate it to have that form first. So what I'm going to do, I'll go ahead and just do it over here on the side. So I'm going to rewrite this is equal to 12. I need to solve for y first. So what I'm going to do is I'm going to subtract 2x from both sides. 2x and 12 are not like terms. So what we'll end up with here is 4y equal to minus 2x plus 12. Then we'll go ahead and divide by 4. The thing to remember is when you divide by 4, you divide everything by 4. So you get y is equal to minus 1/2, and the x could actually be thought off to the side, but that's our slope is negative 1/2 plus 3. So here we have our slope, we have our y-intercept, so 3 is our y-intercept. We rise, or in this case fall 1, run 2, put a second point, and that is going to be the line, or the graph of this line. On number 12, let me just pose this for a quick question for the class so I know how fast to go through this. How confident are you all feeling about this? 1 being I'm completely lost, 5 being you could hand me a test problem right now and I'm okay. Okay, pretty high numbers all over the place. So again, for the sake of completion and just so you can review this later in the video if you need it, I'll just go through these at a comfortable pace so you could just kind of hear the explanation. Okay, so again, we're going to need to solve for y first. So we have minus 4x plus 3y equal to 6. I will go ahead and add 4x to both sides, and what I'll have is 3y is equal to 4x plus 6. Divide everything by 3. We end up with y is equal to 4/3, which is our slope, times x plus 2. So our slope and our b are y-intercepts right there. So we go to y-intercept. We rise 4, run 3, puts us right here in the first quadrant, and connect those, and we're done with number 12. Any questions on number 12? Okay, let's line that up a little better. Perfect. 13 is similar. It is just a little bit more practice. It's one of those things. You always want to treat math like you would a sport or an instrument. The better you will get. So with that, let's solve for y. We have, we'll subtract 10x from both sides. So we'll have a 10y equal to a minus 10x plus 20. Those are not like terms, so don't want to combine those. I'll move this off to the side. Then we divide everything by 10. Ooh, the number is much smaller. Very good. So that's going to be a minus x. So minus 10 divided by 10 is a minus x, and then plus 2. So don't forget here that in this case, the m is just going to be a minus 1. So m is minus 1, which is minus 1 over 1, and b is 2. So we're going to go to positive 2, fall 1, run 1, and we have the line right here as 13. For the graph of 13. Any questions on this one? Okay, so these are lines that were all either rising or falling. We do need to consider the other two cases, which are horizontal and vertical lines. So let's go ahead and look at 14 right here and figure out which scenario we're in. So if you look at this, there's a couple ways to think about this. Maybe the first thing that's important to know is that x is equal to 3. So this is where I'm going to start. I'm going to start just by putting a point there. I know that information is important. So how could you then figure out what direction? Is it going to be horizontal or vertical? Well, one way you could think about this, and I'll kind of give maybe two different lines of reasoning. The first thing to note is that there's no y here. There's no y. So if there's no y, it's impossible to get to slope-intercept form. So what this means is that the slope must be undefined, that m is undefined. So if m is undefined, this means that m was some number over 0. Just to make this a little bit more concrete, what's someone's favorite number? 10. Okay, we'll go with that. Let's say 10, or m was 10 over 0. Really doesn't matter. It's just a number over 0. But now that you know that, you'll realize that it's going to rise 10 and run 0. So you would just go put another point up there at 10, and you would draw a vertical line. Maybe another way that will help you. This one's just coming to me, so this might be a complete flop, but it might help someone. Anyone like playing like Words with Friends or Scrabble, or Wordle? How many play Wordle? Right, you're like, there you go. And if you ever see an X in the word, you're like, I don't know, xylophone. But yeah, I always feel like I have to look up something that has an X in it. Hence, up, vertical. Anyway, might help. The common mistake I'll see on this one is they'll do x, but then they'll go the wrong way. So again, just keep in mind that x equal to some number is going to be a vertical line because the slope is undefined. In the case of 16, we're going to have y equal to 8. And again, this one, if you think about what's really happening here, this is the same thing as 0x plus 8. So you can see our m here is actually going to be 0 over, I don't know, someone else's favorite number? 1. Thanks for keeping this small. There you go. So m, I don't know, it could be 0 over 1. But the information we're given is that y is equal to 8. We're going to rise 0, run 1. So what we have right here is a horizontal line. If you look at this line, the y value, like I said earlier, a line is the, I've been practicing visualization, got it that time, of every solution for the equation. So notice that y is always equal to 8 along that line. All right, any questions on 14 or 16? All right, so 15 is going to be a vertical line through x equal to minus 2, and 17 is going to be a horizontal line through y equal to minus 3. How y'all do?